The atom.
Democritus. In 400 BC, he theorized that everything is made of atoms. They are physical, and between each one lies empty space. They are also indestructible and are always in motion. There is little known about Democritus. For all we can tell, his experiment was mixing dirt and water, seeing that once combined, they are hard to separate. Because of his lack of technology, there is little to no evidence of his theory. There isn't much to talk about his model. It can easily be represented by any spherical object. You can represent it by using a baseball, softball, or basketball. His model is incomplete because he is missing protons, electrons, neutrons, and the properties of each. John Dalton. He theorized that elements consisted of tiny particles called atoms. All atoms of an element are identical and have the same mass. Atoms of each element are different from one another. They have different masses. Atoms cannot be separated, created, or destroyed. Compounds consisted of atoms of different elements combined together. Atoms of same elements can combine together. Chemical reactions involve the rearrangement of combined atoms. His experiments was a series of experiments on mixing of gases to determine what effects properties of the individual gases had on the properties of the mixture as a whole. There is little evidence of John Dalton's experiments other than his atomic model. It shows that each element has its own atom, and that atoms of different elements can combine together to make different compounds of different size and composition. His atomic model is incomplete because atoms can be destroyed via nuclear reactions, and they still don't have protons, neutrons, and electrons in the properties of each. J.J. Thomson. He discovered that there are smaller particles inside an atom. They are called corpuscles. He discovered this when he was experimenting with currents of electricity inside empty glass tubes. He was investigating a long-standing puzzle known as cathode rays. His experiments prompted him to make a bold proposal. These mysterious rays are streams of particles much smaller than atoms. They are in fact minuscule pieces of atoms. Thomson's theory was not explicitly supported by his experiments. It took more experimental work by Thomson and others to conclusively prove the theory. The atom is now known to contain other particles as well. Yet Thomson's bold suggestion that cathode rays are material constituents of atoms turned out to be correct. The rays are made up of electrons, very small, negatively charged particles. Thomson's model is also called the plum pudding model. It shows that there are smaller particles inside an atom, that there are positively charged particles and negatively charged particles. His model is incomplete because the protons are clustered together in the center of the atom, and the electrons fly around the proton in layers, and he is still missing the neutrons. Rutherford. In 1906, he discovered an atom is nuclear, meaning it has a nucleus. He discovered and named the proton, which hides in the nucleus. His experiment was sending particles through a thin sheet of gold foil. Rutherford and his assistant Hans Geiger were able to see that a majority of the particles that passed through with little deflection. However, a few particles were sent in much more drastic directions. This led Rutherford to conclude that there is a concentrated mass in the middle of the atom. His evidence was based on the fact that very few particles were deflected at great angles. The thing they were colliding with had to be very, very small. Rutherford's model. It shows that in the center of an atom, there is a cluster of positively charged particles called protons, and that around it fly electrons that are negatively charged. Rutherford's model is still accepted by scientists today. However, it lacked a neutron. He later proposed the existence of a neutrally charged particle, but he never looked into it. It wasn't proven to exist until later. It also lacked energy levels for electrons.
Niels Bohr. In 1913, Niels Bohr applied quantum physics to Rutherford's model of the atom and proposed that electrons are set in specific levels. These electrons can move in between levels, and as the atom takes in energy and loses energy, electrons will follow respectively, moving either up or down a level. The level, or orbit, closest to the nucleus has a level of 1. The next has a level of 2, then 3, and other numbers. There was no real experiment for this discovery, and the only evidence to back up the claim would be the equation used by Bohr in order to calculate the energy levels. The quantum physics equation, shown here, is pretty, yeah. Anyway, the model that Bohr created, the Bohr model, is also known as the Rutherford-Bohr model, as Bohr simply made slight corrections to Rutherford's model and adding energy levels. This means that the two models are actually very similar. We have a nucleus in the center that contains positively charged protons, and around the nucleus orbit electrons. The only difference is that now the electrons orbit in specified layers. This is more or less the model that we see today. The only thing missing would be neutrons, which still have not yet been actually discovered, and what would later be known as the electron cloud. Erwin Schrödinger. Erwin Schrödinger used mathematical models to predict probable locations of electrons based on density in 1926. This model does not predict the exact path or location of electron. This model, known as the electron cloud model, shows where electrons should be. Looking at the model, areas where the cloud is densest is where electrons are most likely found, and vice versa. You cannot pinpoint an exact location, but you can estimate and figure out where they should be. This can be considered clarity through fuzziness. This goes hand in hand with the Bohr model, as the probable locations shown in this model match with Bohr's locations. As Bohr used mathematical equations to come to this conclusion, his evidence is merely his equation, shown here. It's a little more simple than the quantum physics one earlier. Yeah. As seen previously, the model contains a nucleus and a cloud of electrons, or rather, possible locations for electrons. Which leads us to the atom today. To our knowledge, there are three particles in the atom: the proton, the electron, and the neutron. The weight of these particles being protons have a weight of 1, neutrons have a weight of 1, and electrons have a weight of 0.005, we'll call that 0. Their charges, being protons have a positive charge, electrons have a negative charge, and neutrons have a neutral charge. Their symbols are as shown. As far as location goes, protons are found in the nucleus, electrons are found outside the nucleus in their orbits, and neutrons are found inside the nucleus with the protons. For every proton, there is an electron to keep the atom neutral. Unless an atom is a bond, it is always neutral. Science is ever changing, and what we know about the atom will undoubtedly change as time goes on. What you have just seen here is what we know as of right now. Who knows what the future will bring? Only time will tell.